This is the Progress Check 2 summary video for our logs. So this Progress Check, our biggest thing we're working on is with the properties of logs. There's 4 properties. The first is log of any product. So when you have a log where inside the log it's multiplied by 2 variables, you can do log of the first variable plus log of the second variable. With log of any quotient, you have log and then the inside you have one variable divided by another. You can then go ahead and do log of the first variable minus log of the second variable. Our third one is log of any power, so we have log of some variable to another power. This one, you bring that power down and in front and multiply it by the variable, or log of the variable, so t times log of s. And our last one is log of any reciprocal. This is an addition to quotient because it is a special type of log of any quotient. You only use this one when you have 1 divided by something. So in this case we have negative log of s because that 1 changes to 0 minus log of s. Okay, so with log of any product we have log of a times b times c, and so we just add those, log of a plus log of b plus log of c. With quotient we have log a divided by b, so we end up with log a minus log b. Log of any power, we bring that b out in front, so we have b times log of a. And then any reciprocal, that log of 1 changes into a 0, so we would have 0 minus log of a, so that just changes into negative log of a. Here's our first example. 6t equals 48. We're just going to go ahead and log both sides, and if you can tell, on the left-hand side we have log of a power. So we move that t in front and we have t log 6 equals log of 48. We can then divide by log of 6 on each side, and t ends up being 2.16. On our next problem, we have to subtract by 15 first because we have to get that 5 to t by itself. We need that power variable by itself. So we have 3 times 5 to the t equals 45. Now we have to divide by 3. We get 5 to the t equals 15. Now we can log both sides, and if you look on the left-hand side, we have the power, so we can move t to the outside and have t times log 5 equals log 15. Divide by 5, and t ends up being 1.68. Now here's a conceptual problem. Suppose you are on a team studying the growth of bacteria in a lab. You begin with a sample of 64 bacteria, and the population seems to double every hour. How many hours will it take you to get to 1,024 bacteria? Don't worry, on the progress check or test you will be given this equation. You don't have to make these up anymore. So the equation will be y equals 64 times 2 to the x. And now we have to put in 1,024 into the equation to solve for x. On the progress check, you have to solve this using logs. If you use the table on the graphing calculator, you will get 0 points. So make sure you use logs. So our first step is divide by 64 to get 2 to the x by itself. So we get 16 equals 2 to the x. Now we can log both sides, so we got log of 16 equals log of 2 to the x. So we can then move that x down using our properties. Log of 16 equals x times log of 2. Then we'll divide by 2. And so x equals 4. Now, the way you can always check your answer to make sure you're right is plugging it back into the original equation where we get 64 times 2 to the x. When you do that, you should get 1,024. Lastly, on these concept problems, you have to tell us what the meaning of the solution is. So in this case, it would be in 4 hours there will be 1,024 bacteria. And then lastly, good luck on the progress check.